Hello everyone, welcome to Augmented Technology Private Limited. Today I am excited to introduce our one of the product, that is ADIM. It's an 8-channel digital input communicating with the Modbus. Here we have the ADIM base model and this is the power supply part. So here we can provide the power supply that is up to 24 volt DC. So here we have the configuration positive and negative. So for this board, here we have the RS485 for the communication purpose. So A for the positive, B for the negative. So we can connect the RS485 cable with the PC. So where we can get the data of the board. And here we have the reset part. Whenever we are changing the slave ID and the baud rates, just we need to press the reset. So the board will get configured with the new addresses. Here we have the DI part. Here we have the DI part. This is for the 4 DIs and here we for the another 4 DIs. This DI part operated through the optocouplers which supports up to 80 volt. And in this board we have the deep switch part. So here where user can set their own slave ID and the baud rates. For the baud rates already mentioned in the board, according to the switch we can set. For the slave ID, where user can set up to 15 slave IDs. For the next step, we will focus on the testing process. Please concentrate on the testing procedure and ignore the board visuals which is provided in the video. In this video, we will only know about how to connect the power supply and how to connect the RS485 with the Modbus cable. Okay, here we have the power supply part. There we have mentioned in the board that is positive and negative. Connect the power supply with the positive and the negative and provide the power supply. See here the LED turn on, that means power supply has provided properly. Then get to know how to connect the RS485 cable. Here we have provided the configuration as the B, that is for negative. Here I have connected the negative. A for the positive, I have connected the positive wire. So then connect this wire with the PC. Okay, this is the RS485 cable. So I am connecting this with the PC. Now we will connect the RS485 cable with the PC. So I have connected with the PC. Now open the device manager. In the device manager, go to the port here that is showing as the COM6. That means I am using the port number 6 for the serial communication. So then go to the Modbus pole, click on connection, connect the board and select the port and click on OK. See, the board has connected properly. After proper connections, here you will get the RX and TX LED blinking continuously. That means RS485 communicating with the PC properly. In this video part, we will get to know how to configure the slave IDs and the baud rates. So here we have the slave ID and the baud rates. So by default that is the 9600 baud rate and the slave ID will be a 1. So now we will go with the PC. See here the board has connected properly with the default baud rate and the slave IDs. So now I need to change the slave ID as the 3. Okay, before changing the slave IDs, here this is the dip switch for the slave ID. So here in the dip switch they have mentioned 1, 2, 3, 4. That means the slave ID configuration as the 1, 2, 4, 8. That means if I need the slave ID 3, then I need to hide first and the second pin. That means 1 plus 2, that will be a 3 slave IDs. Okay, then I need the baud rate as a 19200. So the first pin that is mentioned in the board, that is 19200. So I will hide this pin. Now I need to press the reset. So the board will get for the new configuration. See here I will get the timeout error. Whenever you will get the timeout error, disconnect the board and connect the board with the new configuration. The baud rate as 19200 and the slave ID will be a 3. Okay, see after connecting this, Here the TX has continuous increasing. That means the board has connected with the new slave ID and the baud rate. So now I need to set the slave ID as the 5 and the baud rate will be a 38400. So now I will hide the first pin slave ID and the third pin slave ID. That means 4 plus 1, that will be a 5. Now I will need to set the baud rate, that is 38400. That is the second pin. So I will hide this pin and now I will press the reset. See, here I will get the timeout error. Do the same thing, disconnect the board and connect the board with the new configuration. The baud rate will be a 38400. Okay, then the slave ID will be a 5. See, here the board has connected properly with the new configurations as a slave ID 5 and the baud rate 38400. So now I need to set the baud rate as the 57600 and the slave ID will be a 15. So if I need the slave ID as the 15, then I need to hide the all slave ID pins. That will be a 15. Okay. Now I need to set the baud rate, that is for the 57600. Okay. Now I need to press the reset button. Here I will get the timeout error. Then disconnect the board and connect the board with the new baud rate and the slave ID. Here the baud rate 57600 and the slave ID will be a 15. See, the board has connected properly with the new slave ID and the baud rate. Now I need to set the slave ID as the same and the new baud rate, that is 15200. See, okay, 15200, that is the new baud rate. Just press the reset, disconnect the board and connect the board with the new baud rate, that is 15200. Click OK. See, the board has connected properly because I have put the slave ID 15 as same and the only change, that is baud rate. Now I need to get back all these with the default. So load the all pins. Okay. Otherwise you can set only first pin as a high for the slave ID. Otherwise you can low. There is no issue. Now press the reset. The board has gone for the default slave ID and the baud rate. So now here I will get the timeout error. Disconnect the board and connect the board with the default address. Baud rate is a 9600 and the slave ID will be a 1. See, the board is communicating with the properly for the default addresses. This video is for the DI part. So for the DI we need a reference of the 12 voltage. So here I have connected with the 12 voltage for the male to male jumper. So now go with the Modbus. So here connect the Modbus with the port number and once verify the function code. For the DI we need to set function code for the 2. Click on OK. See, the board is communicating properly. Okay, whenever the board is communicating properly, on that time here you will get the RX and TX LED blinking continuously. So now I need to check with the DI parts. For the DI, please refer the data sheets for the mentioned registers. From where to where the DI register has mentioned, they are already mentioned in the data sheets. So now I will check with the each DI where it's working or not. So first I will do short with the DI 1. Whenever I short with the DI 1, see the LED of the DI 1 will turn on. And also I will get the value high, that is 1 in the mentioned register. Same with the DI 2. So here I will get the LED high, and in Modbus also in mentioned register I will get the value as a 1. Checking with the DI 3. In Modbus also I am getting the value as a 1 for the mentioned register. Here also I get the LED turn on for the DI 4 also, and I do with the DI 5 also and DI6 and DI7 and DI8. And don't short with the ground. Sometimes if you short with the grounds, the board will get damaged. So only check with the reference for the all DIs.